to our mathematics lesson. I am Skolile Ngube, and this lesson is proudly brought to you by the Gauteng Department of Education. Right, grade 10s, we're continuing with our lessons, and today we are doing quadratic functions. Remember, in the previous lesson, we talked about the function concept, and also we introduced the linear functions. Do you remember that? Now, today we're doing quadratic functions. Let's be ready for our lesson, grade 10s. Make sure that you have your books, your pencil, your calculators, and your pens with you. We're going to start our lesson just now. Right, what are we going to learn today, grade 10s? We are going to perform a point-to-point plot of the graph of y is equal to ax squared. And we are going to discover the effect of a and q on the graph of y is equal to x squared. Just these two objectives. Right, grade 8 and 9, remember we did input and output values, and also in our previous lesson we did the function concept. So we are going to use what you have learned in these previous lessons or previous grades, we are going to use in this lesson. But before we move any further, grade 10s, I want us to do a baseline activity, a very simple one. Given the function f of x is equal to 2x plus 3, fill in the table below. Remember the input and output values? So we're given the x values, we want to find the y values, which is f of x. Remember we talked about this. F of x is just the y. When I'm saying f of x, you're talking about the y values. So now find the y values. If x is -2, if x is -1, if x is 0, if x is 1, is 2, is 3. Let's do this in 3 minutes. Remember, you have to do your work. Otherwise, you sit there and do nothing, you will not learn anything. We learn by doing mathematics, okay? Let's do this in 3 minutes. Welcome back, returns. Did you manage? Right, if x is negative 2, what will be f of x? So we're finding f of negative 2. Where there's x, we put negative 2. So it's going to be, we're going to replace this with negative 2. So it's 2, then times negative 2 plus 3. 2 times negative 2 is what? Negative 4. Negative 4 plus 3 is negative 1. Okay, and then if x is negative 1, so where there's x, we put negative 1. 2 times negative 1 plus 3. 2 times negative 1 is negative 1. 2 times negative 1 is negative 2. Negative 2 plus 3, what is it? It is 1. And then f of 0, where there's x, we put 0, so it's 2 times 0 plus 3. Right, 2 times 0 is 0 plus 3, 3. So the answer there is 3. Okay, right. And then we still have 1. Where there's x, you put 1. So it's going to be 2 times 1, which is 2. 2 plus 3 is 5. We go to 2. Where there's x, we put 2. 2 times 2 is 4. 4 plus 3 is 7. The last one, where there's x, we put 3. 2 times 3 is 6. 6 plus 3 is 9. Okay, let's mark our work. Did you get everything correct? Well done. So that is the input values and the output values, and we're using the function or the rule to get the output values from the input values. Remember, input values are the x values, and then the output values are the y values. Okay, right. Now I want us to discuss terminology that we use when it comes to functions, and then specifically talking about what? The quadratic function. The quadratic function. We're going to talk about the shape, the turning points, axis of symmetry, and all those things. Okay, right. Remember our WhatsApp line 063-629-3655. 063-629-3655. Please send us your input, send us your questions. Right, the shape. How is a quadratic function shaped? Remember, quadratic functions are called parabolas. Parabola. Right, how is a parabola shaped? Do you know how it is shaped? A parabola is cup-shaped or U-shaped. Okay, remember that. I'll give you time to write notes. And then, if a is greater than 0, what is the meaning of that? When I'm saying a greater than 0, what is the meaning of that? What is the meaning of that? It means if a is positive, if a is positive, you must know that greater than 0 means positive, less than 0 means negative. So if a, the coefficient of x squared, is positive, like here, the 2 here, that's the coefficient of x squared, it is positive. If a is positive, our parabola or quadratic function is concave up. You must know these terms: concave up, concave down. So when a is positive, the parabola is concave up. Do you know that you get a mark for drawing the correct shape? Let's say you're sketching a function, having the correct shape is a mark. It's a key feature that you must know. So when a is greater than 0, when a is positive, the graph is concave up. Some people talk about this, they say it's a smiling face. You see that? When someone is smiling, you see? Okay, so when a is positive, the graph is smiling. But the terminology, the term that we use, we say concave up. Right. And then, if a is less than 0, you must know this. When I'm saying a less than 0, what is the meaning of that? It means when a is negative. Less than 0 means negative. Right, like here, the coefficient of x squared is what? Is negative 3. Okay, I didn't give you time to write notes. I'll give you time. I'll go back to the previous slide, okay? Right, so when the coefficient of x squared is negative 3, do you see that it's negative? The graph is concave down. The graph is concave down. You see how it is shaped? You can talk of the sad shape. Sad face, sorry. Like this, see? Sad face. It's concave down. Okay? I want you to write your short notes. I'll give you 1 minute for the previous slide, and then also 1 minute for this one, then we move on. Let's go back. Right. Write your short notes for 1 minute, and then we'll go back to the concave down one. I'll also give you 1 minute to write your short notes. Don't write everything, just short notes. Let's do it. Welcome back, grade 10s. Remember, let's communicate during the lesson 063-629-3655. Even if you need more time, please let me know. Let us know this side, and then we'll give you more time to do your work, write notes, or even do your activities. Okay? Right. And then let's go to the next one. Again, I'm going to give you 1 minute for you to write your short notes. Next key feature, the axis of symmetry, just like the line of symmetry. Right, know these grade 10s, a parabola or a quadratic function is symmetrical. It means there's a line that will divide it into two equal parts. So a parabola is symmetrical. When you're drawing a parabola, it must be symmetrical. I've seen sometimes people draw funny things like this. This is not symmetrical. You see? It's not symmetrical. The other side is bigger than, if this thing, if it's a line of symmetry, it must be the same. The parabola must be symmetrical. So there's an excess of symmetry. Okay? So for the graph of f of x is equal to ax squared. Remember, a can be half. So half x squared, a can be 2x squared, a can be 4x squared, a can be -3x squared, something like that. So the graph of f of x is equal to x squared is symmetrical about the y-axis. It means the y-axis divides the graph into two equal parts. That's very important, because I've seen this. We are given a parabola like this. Let's say this, the Cartesian plane is not there, it's not even, the numbers are not there. They tell you that a here is -4, 0. And then what are the coordinates here at B? You must know that this thing is symmetrical. So here from 0 to 4 is 4 units. So it means, again, from here to there, it must be 4 units. So you can get the coordinates on the other side. But the main thing, the parabola is symmetrical about, the parabola of this form is symmetrical about the y-axis. And remember, y-axis, x is equal to 0. Along the y-axis, x is equal to 0. And then along the x-axis, y is equal to 0. Remember that. Okay? 1 minute to 2 to write your short notes. Right, welcome back. Turning point. What is a turning point? Turning point. This is where the graph changes direction from decreasing to increasing or vice versa. Right. Before this point, the graph is decreasing. It's going down. Then gets to this point, then it increases. This point where the direction changes, that's the turning point. That's the turning point for a parabola. Right. So now, if the graph is concave up, the turning point is the minimum value. That's where you find the minimum value. If the graph is concave up, the turning point is the minimum value. If a is greater than 0, the turning point is minimum value. Please take note of that. Okay, let's write short notes for 1 minute. And welcome back, returns. So we have the turning point there for the concave up graph. And then what about when the graph is concave down? We have the turning point, which is where we find the maximum value. The turning point where we find the maximum value. That's the turning point for the concave up graph. When a is less than 0, the turning point is the maximum value. Okay, 1 minute again to write our short notes. Right, welcome back, rectangles. Now, the x-axis and the x and the y-intercepts. The x and the y-intercepts. Right, the x-intercept is the point where the graph casts the x-axis. The x-intercept is where the graph casts the x-axis. And then the y-intercept is where the graph casts the y-axis. Maybe let me just draw a diagram to show you. Let me use a linear function. You see, that's the Cartesian plane there. Let's say we have the function, which is f of x. Okay, where the graph casts the x-axis here, that's the x-intercept. And then where the graph casts the y-axis, that's the y-intercept. Remember that, okay? We've talked about this when we looked at the linear function. Right, now I want us to learn about the quadratic function, and we want to see the effect of A and Q. Remember that given the function y is equal to x squared, let's sketch the graph. Right, the first one, we're going to sketch the first one, but when we do the other ones, I'll be just showing you, then you copy the graphs, okay? So now let's do the first one together. I want us to fill in the table. Given this function, y is equal to x squared, and then we are given the table of values there. I want us to fill in the table of values in 2 minutes. And then after 2 minutes, I'm going to give you the answers. Then I'll give you the next instruction. Now, the first part is to fill in the table of values. Let's do that for 2 minutes. Right, welcome back, rectangles. Let's do our table now. If x is -2, what is y? So where it is x, we put -2 squared. Right, -2 inside the bracket, squared. What do we get? We get 4. Right, and then y is equal to -1 inside the bracket, squared. We get 1. And then y is equal to 0 squared. What do we get? We get 0. And then y is equal to 1 squared. We get 1. And then y is equal to 2 squared. We get 4. Okay, so that is our table of values. Now, I want us to write these values, the x values and the y values, as ordered pairs. Remember the ordered pairs, the x value, x coordinate, and the y coordinate, like that. I want us to do that. Write the x values and the y values as ordered pairs. Let's do that in 1 minute. Right, welcome back. Let's do this part where we're writing these values, x and y values, as ordered pairs. -2 will go with 4. -1 will go with 1. Okay, -1, 1. -2, 4. 0, 0. 1, 1. 2, 4. So these are our ordered pairs. Right, the next part now, we want to sketch our graph. Remember the graph we're sketching? Y is equal to x squared. Okay, we want to sketch our graph. Now you'll need time to draw the Cartesian plane, the x and y axis. I'm going to give you 3 minutes. Right, you don't need to draw the grid. You don't need to draw the grid, just the brown part. If you can see the brown part, that's the x and y axis. Can you draw that part before we plot our points? For 3 minutes, draw your Cartesian plane, take your ruler, draw a nice graph, because we're going to draw 2 graphs on the same set of axes. Let's do that in 3 minutes. Right, welcome back, grade 10. Now let's plot our graph. I really hope that there's someone who managed to finish the Cartesian plane and also plot it and drew their graph, okay? Right. Now, -2, 4, -2, then 4. So it means our point is there. Okay, then -1, 1, -1, then 1, our point is there. Then 0, 0 is the origin, our point is there. Then 1, 1, 1, 1, our point should be there. Then 2 and 4, 2, 4, right, our point is there. See that? Now we've plotted our points. Now we can sketch our graph. Let's sketch our graph. That's the parabola, which is symmetrical about the y-axis. That's y is equal to x squared. Okay, I'll give you 1 minute to correct if you need to correct. 1 minute, and then after 1 minute we'll continue. Right, welcome back, Cretans. Let's move to the next part. Right, now sketch the graph of y is equal to -x squared. And we must draw this graph on the same set of axes. We want to compare them. Remember, we want to see the effect of a for y is equal to x squared. Who can tell me what's the value of a there? What is the a there? Y is equal to ax squared. If it's y is equal to x squared, what is a? A is 1. And then if it's y is equal to -x squared, what is the value of a? Is -1. So we want to see what will happen to the graph of y is equal to -x squared. And when you compare it to the graph of y is equal to x squared, what are we going to observe? Okay, right. So I just want you to write the equation. Y is equal to -x squared. We've done the sketching, is fine. So now I will do the sketching, then you copy the function or you copy the graph, okay? Right, so what we're going to do, we're going to find the output values. If x is -2, so y is equal, please be careful, it's -x squared, isn't it? So it's y is equal to negative and then -2 squared. Where there's x, you put -2. So it's negative, then -2 squared. That's why we're getting -4. For -1, is y is equal to -1 squared. Okay? And then what do we get? We get -1. For 0, we'll get 0. And then for 1, again, there's going to be y is equal to -1 squared, which is -1. For 2, y is equal to -2 squared, which is what? -4. See that? You see the difference between -2 squared and -2 squared like this? There's a difference. This one is 4, this one is -4. Please be careful when dealing with that. Okay? Alright. Don't worry, don't write anything, just the equation is fine. We want to compare these two graphs. Right? And then I'll do the plotting. So -2 goes with -4. -2 goes with -4. So the point is there. Then then -1 goes with -1, -1, -1. So the point is there. Then 0, 0 is the origin. And then 1, 1, 1, -1, sorry. 1 and -1 and -1. The point is there. And then 2 and -4. The point is here. Okay? Right. So now we can plot our graph. We can sketch our graph of y is equal to -x squared, which is this graph here. The graph of y is equal to -x squared. Remember, we have our equation y is equal to -x squared. We have our equation y is equal to x squared. Now I want you to sketch the graph on the same set of axes just for 1 minute, and then I'll tell you what to do after that. 1 minute, let's sketch the graph. Right, welcome back, returns. Now we have our two graphs. Y is equal to x squared, and then y is equal to -x squared. Now when we compare these two graphs, what do you observe? What do you observe? Compare the red graph and the black graph. What do you observe? Are these graphs reflections of each other? They are reflecting each other about which point, about which line? About the x-axis. The x-axis is like the mirror. Remember reflections? Okay, so now the graph of y is equal to -ax squared is a reflection of y is equal to ax squared about the x-axis. Let me give you an example. We have y is equal to 3x. And y is equal to -3x. Oh, sorry, squared. Now this is linear. Okay, squared now is quadratic. So this graph is a reflection of this graph about the x-axis. We have y is equal to half x squared. Y is equal to -half x squared. This graph is a reflection of this graph about the x-axis. Okay? Right. Please write your notes for 1 minute. Right, welcome back, returns. Now, I want us to discuss now still on the effect of A. The graph of f of x is equal to x squared. Let's call this graph our parent graph. Parent graph. Like the other graphs, the brown graph g of x, the red graph h of x, they are from f of x. what happens to f of x to give us g of x? What happens to f of x to give us h of x? So the graph of f of x is equal to x squared, g of x is equal to 2x squared, and h of x is equal to half x squared as sketched. Given that the standard form of a parabola is f of x is equal to ax squared plus q. If you check, I've introduced one more parameter there, which is q. We have been dealing with f of x is equal to ax squared. But remember our objective. We said we want to see or observe the effect of a and q. So that's why I'm bringing in the q here. But for these three equations, for these three functions, our q is 0. That's why nothing is appearing after x squared. Our q is 0. Please take note of that. But in the next examples, you'll see for q, we're having a number which is not a 0. And then we're going to see the effect of that q. Right. So we have the graph of f of x, g of x, and h of x. I want you to discuss with your colleague, just for 1 minute. What do you observe? What are your observations? As a changes from being 1 and becoming 2, what happens to the function? As a changes from being 1 and becoming half 1 over 2, what happens to the function? Just 1 minute, discuss, then after that, I'll tell you what I think, okay? Right, let's do it for 1 minute. Right, welcome back, grade 10s. What did you observe? This is what I've observed. Right, for a greater than 0, it means if a is positive, the graph of y is equal to ax squared is a vertical stretch of the graph of y is equal to x squared. The graph becomes narrower. In simpler terms, check f of x and g of x. F of x, a is equal to 1. G of x, a is equal to 2. So for g of x, the brown graph, it is narrower. So we're saying that as a increases, 1, 2, 3, 4, 5, as a increases, the graph becomes narrower. The graph is vertically stretched. It's like you're pulling something upwards like this. You see, vertically stretched. Okay? Right. So that's the meaning of that. For a greater than 0, the graph of y is equal to ax squared is a vertical stretch of the graph of y is equal to x squared. The graph becomes narrower. Can you write the notes for just for 1 minute? And then we continue after that. 1 minute. Right, welcome back, grade 10th. Right, so let's try this one. Given f of x is equal to 2x squared, g of x is 3x squared, and h of x is 5x squared. Which graph is for f, g, and h? Try to answer that one. 30 seconds. Before I give you the answers, I'll be giving you answers just in 5 seconds. Right, which one is the narrowest? Do we have something like narrowest? I think so. We have narrower. Narrowest must be there. So which one is the most narrow? Most narrow one. Which one? Is it h of x? The biggest A, the largest A there. That should be the most narrow one. And then this one, f of x, which is the smallest A, must be the widest. And then in the middle, we must have g of x. So that is f, the widest, because it is the smallest A. And then we have g, which is in between 2 and 5, we have 3. And then the most narrow one is h of x, because A is the largest there. Do you see that? So the bigger the value of A, the narrower is the graph. The smaller the value of A, the wider the graph. Okay? Right. Now, this one may be a bit difficult to understand, but it won't be difficult. When it's like this now, when it's concave down, what is happening to the value of A? You have to be careful. But we say that when A decreases, the graph becomes narrower. Does it make sense? When the graph was concave up, we say that when A increases, the graph becomes narrower. But now we're saying when A decreases, the graph becomes narrower. Why? Let me try to explain this. When the numbers become smaller on the negative side, which one is bigger? -2. Let me write because my scale here is not clear. Which one is bigger? -2, maybe say -9. Which one is bigger? Do you know that -2 is bigger than -9? Remember the number line. As you go to the left, the numbers become smaller. Okay, so that's why I'm saying that when the graph is concave down, as A decreases, the graph becomes narrower. Or let's do it like this. What you can do, just ignore the signs. Ignore the signs. Just ignore this and ignore this. And look at the values of A without the sign. This one is 1, this one is 2. The one with 2 must be narrower than the one with 1. The signs are just for the shape. Concave down, concave up. That can assist, isn't it? Yes. So now we can say that for A less than 0, that is when A is negative, the graph of y is equal to ax squared is a vertical stretch of the graph of y is equal to -x squared. The graph becomes narrower. Okay? Right. And then, now let's try to do this one. Which graph is for f of x, for g of x, and h of x? I'm going to give you answers in 5 seconds. Try to be ahead of me. Oh, I should be counting. 1, 2. 5 seconds. So the graph for f of x, because the 6 there, I'm ignoring the sign, the negative side. I'm just looking at the number. 6 is the biggest, largest. So the graph must be the narrow, most narrow. Must be followed by h of x, because 2. I'm just ignoring the sign. And then that is h of x. Oh, I started with g, the widest. Oh, okay, because of the 1 there. Ignoring the negative there. The 1 is the smallest A, which is the biggest. Don't look at the negative numbers. This thing may be confusing. Okay, choose which one you want to use. Okay, do you want to ignore the signs or not? Both of them, they can assist you. Right, so this will be G, and then this will be H. Okay? All right, I really hope that You didn't get confused here? Okay, it's very clear. Right, I want us now, we have looked, what have we done so far? We have looked at the effect of A. When A is positive, the graph is concave up. When A is negative, the graph is concave down. When A is bigger, when A is greater than 0 and is positive and is bigger, the graph becomes narrower. But when the graph is concave down, you have to be careful. When A is smaller, like comparing -2 and -9, -9 will be smaller. The graph will be narrower. You can ignore the sign and just compare 2 and 9 and say 9 is bigger, then the graph is narrower, something like that. Okay, so that's the effect of A on the graph. I want us to discuss the effect of Q. Now, I'm going to give you 3 graphs, and then I want you to observe that. I'm going to give you 1 minute for you to discuss, and then after that, I will give you my observations. Right, we have the 3 graphs. We've done this part. Oh, let me just go back. I think we need to discuss it. Right. We just discussed because we've covered everything. For A, when A is between -1 and 0, -1 and 0 is a proper fraction. You know a proper fraction? Where the numerator is smaller than the denominator. And when A is between 0 and 1, it's positive. Proper fraction, maybe for example, 1/2. So when A is a proper fraction, like this one, the half, then the graph becomes wider. When you compare the graph of y is equal to x squared and y is equal to 1/2 x squared or 1/3 x squared, the one with a coefficient of x, which is a proper fraction, is wider. Okay, right. It's covered by that fact that we said when A is smaller, the graph is wider. It's just covered by that fact. Right, let's look at these 3 graphs. The graph of f of x is equal to x squared is our parent graph that is going to be translated or transformed. Right, we have g of x, which is x squared plus 3, and then we have h of x, which is x squared minus 2. Right, what do you observe? Just discuss this for 1 minute, and then after that 1 minute, I'm going to give you my observations. 1 minute. Right, welcome back, grade 10s. Right, so we have our 3 graphs. We should have seen that y is equal to ax squared plus q is a vertical shift, not vertical stretch, vertical shift. The whole graph is shifted. How is it shifted? If q is positive, remember greater than 0 means positive. If q is positive, the graph is shifted upwards by q units. Like in this example here, our q is positive 3. Remember our general equation is f of x is equal to ax squared plus q. So our q is positive 3. So it means the graph is shifted upwards by 3 units. So y is equal to ax squared plus q is a vertical shift of y is equal to ax squared by q units upwards if Q is greater than 0, if Q is positive. 1 minute for you to write your notes. Right, welcome back. So now, what about the red graph? What happened to it? Right, f of x and h of x is equal to x squared minus 2. Y is equal to ax squared plus q is a vertical shift of y is equal to ax squared by q units downwards if q is less than 0. Like here we have our q, which is negative 2. See that the q value is negative 2 there. So it means the graph of f of x is shifted downwards by 2 units. That's the shift downwards by 2 units. Okay? Right. That's the effect of q. So what is the effect of q? Vertical shift. If it is positive, it goes up. If it is negative, it goes down. If it's negative 2, it's going to go up by 2 units. The original graph is going to go up by 2 units. If it's negative 3, it's going to go down. The graph of f of x is equal to ax squared will go down by 3 units. Okay? 1 minute to write your notes, and then after that, we're going to take a short break. We'll come back, take a short break, and then we'll go to the homework. 1 minute to write your notes. Welcome back, Christians. Let's just take a short break, and then after our short break, I'll give you the homework, and then we summarize our lesson. Let's take a short break.
The road to success, to becoming a successful student, is through commitment. Commitment to studying, commitment to putting in the extra hours in your books. I know it's not going to be easy. Actually, no one said it will be easy. But if you keep pushing and if you keep believing a little more in yourself, then the results will show in your life. Commit and become.
Right. Let's copy our homework returns. Just write the functions. Okay, just write the functions. You don't need to do everything. You're sketching these 2 functions. And then you can say the domain from negative 2 to 2. And then this one you can say from negative 4 to 4. Just write x values from negative 4 to 4, here negative 2 to 2. And then you can draw your table later. Let's just do that for 1 minute. Right, let's summarize our lesson. Right, I said if A is greater than 0, the graph is concave up. If A is less than 0, the graph is concave down. The graph of f of x is equal to x squared is symmetrical about the y-axis. And then the minimum or maximum value of the graph of f of x equal to x squared is 0. And then but if there's a q value, then the maximum or minimum value is going to be q. Remember that, greatens. And then what we have, y is equal to a squared plus q is a vertical shift of y is equal to ax squared by q units upwards if q is greater than 0, if q is positive. But if q is negative, then it's a downward shift. Thank you very much, greatens. We are going to meet next term. Don't miss the lessons next term. Enjoy the rest of your day and enjoy your holidays. Goodbye.